Now, for a water and a wastewater treatment, there's what you call a paradigm. Now, for you to determine or for you to know what would the paradigm mean in treating your water or your wastewater, I have here a figure that would help you decide which part of the paradigm is optional and which part of the paradigm is a must. So, for example, you're given a 200 milligrams per liter BOD. We have here BOD, biochemical oxygen demand. And the wastewater gets into primary treatment. So what is a primary treatment? Normally, you utilize physical processes, as we have discussed. And normally, it has been found to remove 30% of the contaminant or pollutant. In this case, you remove 30% of the BOD. That means what is left is 140 ppm. Now, definitely, depending on the function or the objective of the treatment, remember we have two treatment objectives. You have to save the environment, and then you have to comply with the regulations of the government. Now, in our case, in the regulatory requirement of the Philippines, the Class C water, which refers to your Laguna Lake, has a BOD limit of 50 milligrams per liter. So if I may ask you, at this point, after having the primary treatment, can you stop treating? No, because you have not reached yet the requirement. Now, so you have to go to the secondary treatment. Secondary treatment is normally done using biological processes. In this case, it has been found to decrease any contaminant, for this example, 80 to 90% BOD removal. From here, question, if it is just for the purpose of discharging it to the lake, for example, in Laguna Lake, which has a limit of 50 ppm of BOD, can you already do the discharging? Yes, because you have met already the standard of 50 ppm. And therefore, that means for that particular objective, we say that we stop at this paradigm. However, what if you would like to have the water or the wastewater to be recycled in the process? Or let's say you would want to have this to be utilized as watering your plants, or you would want to use it for the laboratories rather in the industry. You need to do some additional treatment. And this would tell you that you need to proceed with the next paradigm. That is the advanced treatment, or sometimes called tertiary treatment. Here we employ chemical processes, and we also have the objective, aside from meeting that requirement, to remove nutrients. Now, I've heard that in the most recently revised EIA law, all wastewater treatment plants are required to have this nutrient removal facility, which is actually digester. We have some figures in the succeeding slides. Okay, so to recap, how do you apply the wastewater paradigm? For the primary treatment, your objective is just this, removal of solids. Then you have disinfection. But you notice, class, disinfection is present on each part, because that is to ensure that some of the coliforms, depending on the strength of the pathological and the non-pathological contaminants that you have in the water, so that is where you have to employ disinfection. For the secondary treatment, you have to remove the BOD. And at this point, you can already use it for irrigation. And then with respect to the nitrogen, it still contains 50% of it, while for the phosphorus, it still contains 70% of it. For the tertiary treatment, your objective is to remove remaining BOD, N, and P. This, at this point, is already drinkable. The water here is drinkable. And then normally, depending on the size of the dissolved particles, sand and activated charcoal can be utilized, or sometimes you can make use of chemical precipitation. Okay, we've mentioned about disinfection. So for disinfection, although chlorination is the most commonly utilized, they also utilize some processes such as ozonation. However, the process of ozonation, you know what is O3, right? It has a radical, a very active radical. Therefore, the problem that we had encountered here is that it easily corrodes the pipelines, unless otherwise you enclose the ozonator properly. And also, since you cannot, it's very difficult for you to contain the ozone when the radical starts to corrode the metals as well as the equipment itself, there would also be a probability of leaking. So that would be more unsafe for the crew or the staff of the wastewater treatment plant. So normally, in industry, it is not so often that they utilize ozone. Now, for chlorine, chlorination, as you notice in the discussion of the paradigm, may be done from primary, secondary, tertiary. Now, why or how would you decide whether you utilize chlorine at the primary and the secondary and not only at the post-treatment? Because of this. So if you have too much of the microbiological contaminants, if you notice that there are some biological slime build-up, if there is a persistent taste and other problems, and if you want to oxidize and precipitate some of the dissolved solids, you have to use prechlorination. This is a typical example of a chlorine tank. But this time, this is only utilized for the groundwater or from the deep well source of water. As I have mentioned, especially for the effluent or for the sewerage treatment, you need a contact time between the chlorine and the water, therefore you need to have a well. Now, this is the portion which I told you that the EIA law, the new amended EIA law, would like to impose for all wastewater treatment plant. The additional of nitrification basin, or sometimes called digester. So here, for the tertiary treatment or nutrient removal, you have the objective of converting the ammonia to nitrates. The nitrates should be converted to nitrogen gas through the nitrification, and then at the same time, the phosphates would be removed. Now notice, this would be the what? Primary treatment. This would be the biological treatment, and this portion would be for the tertiary treatment. Okay. This is an example of an aerobic digester. Now, when you treat the sludge coming from the treatment of wastewater, you have two choices. Either you do it aerobically or anaerobically. But normally, with the purpose of collecting some gas, you have to use an aerobic digestion. But for the heating value of municipal wastewater, I think the heating value of it is not enough to produce sufficient amount of energy for us to utilize as an alternative source of energy. Normally, this is being applied if you have solid waste. This figure shows you also the secondary treatment as part of the paradigm, and this employs biological treatment. Now, what do you notice, class? Coming from the primary clarifier, the sludge is being recycled. And this system is what we call return activated sludge. How is biological process being undertaken here? You know that the sludge would contain some bacteria. And since it's only has passed through the primary clarifier, the bacteria here is assumed to be alive. And therefore, you can still recycle it so as to treat further whatever water is passing through here. This is actually the system called return activated sludge. Now, if the effluent has passed the secondary clarifier, this is where we assume that the bacteria has already died or have already died. Because we all know if we plot the lifespan of a bacteria, after some time they tend to decrease. So at this point, this is where you already dumped the sludge to the vitrification basin. And therefore, the effluent now will directly go to the disinfection process and then ready for discharge. After discussing the water and wastewater paradigm, succeeding slides would now help you determine which would be the primary treatment, the secondary treatment, and then the tertiary treatment. In this case, for the drinking water treatment flow diagram, you can separate it from the mixer to flocculator as the primary. The clarifier would be your secondary, followed by another filter going to the tertiary treatment or the disinfection. Now here, these steps in wastewater treatment also shows you the division of the primary, the secondary, and the tertiary treatment. For the primary treatment, it starts with the sedimentation tank, going to aeration tank, which serves as your secondary treatment, and then for your chlorination as the tertiary treatment. But in addition to the effluent treatment, you also have the handling of sludge, which is also under the tertiary or advanced treatment. Now this one would specifically have identified already the primary, secondary, and tertiary treatment. So what do you notice? The chronology, since it's a paradigm, should always start with primary, secondary, then tertiary. Question: can you also make use of some treatment under primary to be in between secondary and tertiary? Yes. So what do I mean? If you have primary, secondary, you can insert a primary treatment prior to tertiary treatment. Now, this typical municipal sewage treatment would again show you the paradigm. So for letter A, you have the primary treatment. Then for letter B, you have the secondary treatment, which involves biological oxidation. And then for letter C, disinfection and release, particularly for the effluent, would be under the tertiary treatment. However, the sludge handling, which would also be coming from the primary, combination of primary and secondary treatment, is falling under the tertiary treatment. Okay, your septic tank is a vivid example of how the wastewater paradigm is applied. So, from the leaching field, you have some perforated pipes to do the primary treatment to segregate some of the solids. And then it goes directly to your access manhole, or we call it Pozo Negro. So the Pozo Negro is enclosed, therefore it undergoes anaerobic treatment, which would fall under secondary treatment. And then you have your outlet going to the effluent or to the treatment plant, and that would be ready for tertiary treatment. However, the sludge that could be accumulated in your Pozo Negro will now be handled by the most commonly known company, Malabanan, to treat the sludge. So this is an example of the wastewater treatment paradigm. Okay, for the sludge handling, we normally utilize an open dry bed. However, your open dry bed would be prone to vermins as a source of illness, and sometimes because of uncontrolled open drying bed, you have some obnoxious odors. And therefore, you can apply first one way to easily dry your sludge so that the sludge could be directly given to the contractor composting your sludge ready to be manufactured as fertilizers or soil conditioners. And one way to do that is by the use of filter press. I guess you've known or you've seen what is a filter press. And of course, as I mentioned a while ago, your sludge may be further utilized as an energy recovery or in an energy recovery system. That is when you utilize it for an aerobic digester as a source of energy.